Hello class, welcome to our 6.5 lesson. We are going to graph square root and cube root functions and take a look at cubic functions as well. Now we also did this already this year, so you got to remember way back to the trimester 1 where we did our parent function posters or projects. We have done these values, so we'll take a look at them again here in a little more detail. So I just want to remind you, radical function here. So first one we're going to do is going to be the square root function. All right, so the function itself is just f of x equals the square root of x. The domain for the square root function is right there. All right, and I'll show you that in a second when I graph it. And another way to write that domain, remember, is you could simply just say that x is greater than or equal to 0 if you wanted to just say it that way. The range is then right here. And on the range, if you wanted to simply just write, well, this should say f of x greater than or equal to 0, not y, because it's f of x there. And then the standard form function is this one, remember, where we use h and k as our translations, our shifting left and right. And today what's going to be different is we're going to add this a value. Remember, a is what will stretch or compress and reflect the function itself. All right, so think about the square root function, and remember we had the points 0, 0, 1, 1, 4, and 2, and 9, and 3. Those were your major points. All right, there's 0, 0, there's 1, 1, 1, 2, 3, 4, 2, and 9, 3. There is your square root function. And you can see now the domain, all the x's are greater than or equal to 0. And the range, all y's are greater than or equal to 0. And then down here, the main locator point is the coordinate at 0, 0. That's where you're going to be able to find the h and k values. All right, don't forget to label your points on your graph. All right, don't forget to label your points on your graph. Thank you. All right, now the other thing that we're going to talk about is we have x-axis reflections. If you reflect over the x-axis, you have a negative out in front of the function itself. That's an x-axis reflection. And then there is the y-axis reflection, and that's when you have the negative inside the function right there. We will not be doing any y-axis reflections in this year. Just want you to be able to see what it is. Also, another very important piece is don't forget about these coordinates are your main points for your parent function, and then we are going to translate those points. So remember that table. The next one is the cubic function. So its name is cubic. The function f of x equals x to the third. In this case, the domain is from negative infinity to infinity. And again, another way to write that is you could simply say that the domain is all real numbers. The range, again, I made a mistake there. All right, I apologize. I used f of x there, so this should say f of x, not y, my mistake. And then you could also say that the range is all real numbers as well. Here is standard form for a cubic function. All right, and you can see that there's, again, the h and the k. And then a is going to be what will stretch or reflect, or sorry, stretch or compress. And we still have a x-axis reflection and a y-axis reflection. Again, we are only going to be worrying about x-axis reflections, not y-axis reflections, okay? Now remember, for a cubic function, we use the values of -2, -1, 0, 1, and 2. And then the y values were 8, 1, 0, sorry, -8, -1, 0, 1, and 8. So our cubic function, there's 0, 0, looks like this. Here is 8, 2, and -1, -1, -2, -8. There is your cubic function. I notice it's going up and down very, very fast. The main locator point is at 0, 0 for HK. And then make sure we label our coordinates. All right, and again, this table is your parent function table. You use those coordinate points in order to translate and stretch and compress and reflect. And lastly today, here is the cube root function. Its name is cube root. The function is cube root. The domain is, again, from negative infinity to infinity, so I could say again that that is all real numbers. The range, again, I made that same mistake, so we'll fix it. But you get to learn from my mistakes. F of x, because I used f of x. Another way to say that is all real numbers. You don't have to worry about the notation then. And here is standard form. All right, I missed the a value here, so there's an a, which would, there's h and k, which move it left or right. Up or down is k. H is left or right. A, again, is compress or stretch. All right, again, we have a x-axis reflection with the negative there, a y-axis reflection with the negative inside the function. Again, the main locator point will be at 0, 0, and hk is where you get from there. The coordinates here are, remember, cube root is the exact inverse of cubic function, so I just switch x and y from the last table. So this is now -8, -1, 0, 1, and 8. So I get -2, -1, 0, 1, and 2. So we have those coordinates is 1, 0, 0, 1, 1, -1, -1. So it looks very similar to the cubic function, but now I go over to 8 and up 2 over there for cube root, taking up very slowly and going left and right very fast, and then -8, -2, again, going up and down slowly, but left and right very quickly. And then again, we're going to label our points. Make sure you label your points, please. There is your parent function, and again, use this table to stretch and compress. Those are your three parent functions that we're going to be looking at today. Let's use them. Okay, so here we have the function. It's f of x equals the square root of x plus 4. All right, so we want to compare that to our parent function, f of x is equal to, this is a square root function, so I use the square root of x. And remember that function is 0, 0, 1, 1, 4, 2, so 1, 2, 3, 4, 2, and 9, 3. So those red dots are the original function. And then now when I add 4, notice that the square root, let me clean this up a little bit, get rid of that. The square root, all right, ends right there. So if you want to, and I like to do it and just put a little down mark right there at the end of my square root, that way I know it's ending right there, which tells me that that plus 4 is outside this radical, which means that is a k value, and k is a vertical shift, so I go up 4. The transformation right here will be up 4. So I take, instead of being at 0, 0, I move it 1, 2, 3, 4 units up. And the next one, 1, 2, 3, 4 units up. 1, 2, 3, 4 units up. And 1, 2, 3, 4 units up. And now that, in blue, is my final graph. And notice my labels here. I will label this as 0, 4. Notice the coordinate here matches the transformation. Notice there is 0 left or right movement and a positive 4 movement in the y, so there's 0, 4. Here I'm at 1, 5, 4, 6, and still 9, 7. All right, and so the domain is x is still greater than or equal to 0, because it's from, if I use a different color here, it's basically from this coordinate that way that x travels. And the range for y is f of x, because that's the notation I'm using up here. In this case, it's greater than or equal to 4, because from that coordinate, y goes only up from 4, and it's a closed circle here, so it includes 4. All right, you don't need to draw these arrows in if you don't want to, because that might make your graph look more confusing. Just have the one graph there. And that's that function, and I've compared it to the parent function by describing the transformation. Here's my next problem, f of x equals the cube root of x minus 2. So I'm going to compare it to the parent function, f of x equal to the cube root of x. And remember that table All right, we have that in our first couple of pages of notes. It's 0, 0, 1, 1. Now it's the cubic function, so it's got to be very shallow and not go up very fast. So I got to go very far to the right, 8, 2, and then -1, -1, and very -8, -2. So those red dots are the parent function, so we call it PF, parent function. And now, what is happening? Notice in this case, my radical goes all the way to there and then down, which means that that 2 is inside of it. So that means it's going to be a left or right movement. And remember from when we did this before, again, you can go back to chapter 1 notes if you can't remember, this is a right 2 movement. My shift is right 2. So I take this dot, 1, 2, now it's right there. I have here 1, 2, and then 1, 2, and then from there 1, 2, and then more over 1, 2. So now there in blue is my final graph there, and label my points. This is at 2, 0. There's my main locator. Notice 2, 0 matches my transformation. Right 2, and then I went up or down 0 units, so positive 2, 0. Right, and then here I'm at 10, 2. Here we are at 3, 1. We are at 1, -1, and here we are at 6, -2. So labeling those points. The domain, all right, is still all real numbers because it goes forever left and right. And then the range is also still all real numbers because it goes forever up and down. All right, so I just want to show you that. I know it doesn't look like it, but it is going up at every moment. Oops, I'm erasing. At every moment, the graph is going up and continuing to move up as you go around. So I'll erase those to make it easier to see. So there is your final graph in the domain and range and transformations. All right, let's get a little more complication of things here. So we're going to increase. So notice on these ones, we have a value of a that is given to us. All right, so we're going to compare it to the parent function, square root of x. Remember those coordinates. So 0, 0, 1, 1, 4, 2, and 9, 3. So those red dots are the parent function right up there. And now what I'm going to do here is I need to basically take care of this stretch by -2 is the transformation. Again, stretch by -2. Really what that means is I'm going to multiply the y values by -2. All right, so if you think about the table that we currently have here, we had, 0, 0, 1, 1, 4, 2, 9, 3. That's my parent function. What I'm doing in this problem is I just got to take these numbers, which are my y's, and I'm going to multiply by -2. So I've got 0, -2, -4, -6. So I can go, all right, still at 0, 0. Now I have 1, -2. I'm at 4, -4. 1, 2, 3, 4. And at 9, 1, 2, 3, 4, 5, -6. All right, notice that is now my final graph looking that way for number 1. And then label those points. I have 0, 0. I am at 1, -2. I am at 4, -4. And then lastly, 9, -6. Notice, take a look at what happened there. All right, notice the distance between blue dot to blue dot is twice the distance from red to red. All right, and now the domain of that problem, so let's see here, the domain is simply still x greater than or equal to 0. And the range is now y, because I used y up here, is less than or equal to 0, because it's going down. I didn't say it up here, but the transformation, again, the transformation is stretched because the number is a improper fraction, stretched by -2. All right, let's take a look at number 2 here. All right, this one, the transformation will be stretched by 4, but you have to do that first. You take care of A first, always, and then do any shifting left or right. Stretch by 4, and then up 1. Okay, that'll be the situation. So again, remember, we first take care of the a value in the transformation order, then we worry about the shift left or right. So again, we're going to take a look at, we're going to start again over with the red equation. So my red dots, the same red dots as before, the same table up here. Only now we're going to multiply those values by 4. So I don't need these blue ones anymore. I'm going to multiply them by 4. So 0, 4, 8, 12. All right, and then, so those are the next ones. So I'm going to have 0, 0 still. I have 1 and 4. 2, or sorry, at 4, I'd be at 8, so way up there. And then at 9, I'd be at 12. So there's 10, 11, 12. So it's up there. It's not easy to see. There's the dot above. And then now, what I need to do is I now need to shift those points in green up 1. So that point's going to be right there, up 1. This one goes up 1, up 1. And then this green dot up here would go up 1. So now I'd be up at 13. So that coordinate is 9, 13, way up there. All right, this one is at 0, 1. This one is at 1 and 5. And then here we're at 4, 9. And so then this yellow is my final graph, is the yellow. Now notice, if I follow it correctly, the main locator point, which is right here, 0, 1, notice I went right or left 0, and then up 1, so that'd be 0, positive 1, and that's what matches it. All right, and then for that situation, the domain is still x greater than or equal to 0, and the range would be, in this case, f of x is greater than or equal to 1, because 1 is as low as I get to in the y values. Okay, take a look again, stepping up in the process here, we're going to get a little more information, a little more complication here. Again, we're doing this parent function. All right, so I'm going to use the same table, 0, 0, 1, 1, 4, 2, 9, 3. All right, and in this situation, so let's put those on the graph, 0, 0, 1, 1, 4, 2, that's 5, 2, 4, 2, and 9, 3. So this dot, get rid of that one. Okay, and that's our parent function, and notice what we have here is a stretch by -3. Okay, so we write down stretch by -3, and I can multiply these y values by -3. So I have 0, -3, -6, -9. All right, so still at 0, 0, 1, -3, 4, -6, 1, 2, 3, 4, 5, 6, and that'd be at 9, -9, right there. So those green dots are the stretch by -3. But now I need to do the transformations. That is going to be, again, left 5 and down 2. So now I take my green dots that I've made, and I will move them one left 5, 1, 2, 3, 4, 5, and 1, 2. Right there is my first point. Here, 1, 2, 3, 4, 5, 1, 2. All right, and 1, 2, 3, 4, 5, 1, 2. And 1, 2, 3, 4, 5, down 2. So right down there, I'm down at -11. So comma -11. What is that value at? 4, -11. Here I am at -5, -2. Notice that main locator point matches the exact transformation, left 5, down 2. All right, and then on this one, I'm at -4, -5. Here I'm at -1, -8, labeling my points. And then now that in blue is my final graph, right? And just keep it as a curve, being smooth. So in that case, the domain is now x is greater than or equal to -5. And the range is now f of x, because that's what I used up here, is less than or equal to -2. So that is the square root. All right, now if you look at this next one here, this is a cube root. So I want to look at g of x equal to the cube root of x. And again, the cube root, its parent function, that's the black dots I'm going to do, 0, 0, 1, 1, and 8, 2. and -1, -1, and over here -8, -2. I have those dots that I put down there in black. The first thing I'm going to do is stretch by +2. So I multiply those values by 2, so still at 0, 0. This would be multiplied by 2, so I'm at +2. I'm at 8, 2 here. I got to make that then multiply the y value by 2, so I'm going to be at 8, 4. Here again, -2, and then over here, -4. Now I have those yellow dots, and now I need to move them, and I'm going to go, that's right 2, and up 5. So right here, 1, 2, 1, 2, 3, 4, 5 is my first point. The yellow, 1, 2, 1, 2, 3, 4, 5 right there. This one, 1, 2, 1, 2, 3, 4, 5. This yellow dot, 1, 2, 1, 2, 3, 4, 5. And then this one is 1, 2, so I'm over at 11, and 1, 2, 3, 4, 5 right there. So that coordinate is at 11 and 9. Main locator point is from 0, 0, this one right here, and that, notice that point is at 2, 5. This coordinate, I'm going to go above that, is at 3 and 7. Here I am at 1, 3. And this one is at -6, 1. And so now my new function is the green right through there. All right, the nice thing about cubic and cube root, doesn't matter how you shift that, the domain is still going to be all real numbers, and the range is still going to be all real numbers. All right, let's do 2 more examples, and we will be done. All right, in this case, we're going to take this parent function, which is the cube root of x. And so remember, those coordinates are -2, -1, 0, 1, and 2. So that's going to be -8, -1, 0, 1, and 8. Those are my parent function. All right, so again, cubic. Sorry, I said cube root. I meant cubic function. That goes up fast. So then I go up to 8, 2. I'm at -1, -1, down fast to -8, -2. Okay. Now, what is this one going to do? That is going to stretch by -4. So instead of using these y values, I multiply them by -4. So I'd be at, oh boy, that's going to be -32, -4, 0, 4, and 32. Okay. In this case, I'm okay if you just leave the scales as is. I still have 0, 0. Now I'm at 1, 4. And -1, and 1, 2, 3, -4. And then to get to those 32s, that's just going to be really hard, so just make it as best you can, curve it down, just like that, and then label the points that you can label, 0, 0, and 1, 4, and -1, -4, all right? If it's very far off the graph, you could, if you wanted to, just, maybe make the point down there. I'd be at -2, -32. If you wanted to just do that to label it, 32, sorry. All right, it's harder to go up top. All right, so, or you can, if you really want to change the scale, you can do that as well. All right, let's take a look at number 6, and we're going to start again with those red dots. And again, it's multiplied by -4, so I'm still going to use these coordinates right there. All right, but now what we're going to do is we're going to move them. That's going to be right 3. Sorry, my fault. That's left 3. All right, it's okay to make the mistake as long as you fix it. That's left 3 and down 7. So from 0, 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 right there. So now notice that's where 0, 0 was. So my main locator point is now at -3, -7, which matches my transformation. All right, sorry, that's really hard to see. And then now from up here at 1, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 is the coordinate right there. And that point is at -2, -3. And then from 1, 4, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So I went 2 off the graph, so that would be at -12. And that is at -4, -12. And then still, even if I went from 32, left 3, down 7, All right, I'd end up at a positive 25, and then same thing down there. So really far down. So just kind of make your curve here. We'll have better ones for you on the homework, so it's not so challenging. So there is the cubic function and transforming of the graph there. Homework assignment is this 6.5 graphing root functions worksheet. Good luck and have a great day.